Electric vehicles, they are powered by batteries, and batteries are the most critical components of EVs. They need a lot of development, a lot of testing, a lot of love and care. They are the secret sauce that drives EVs, and every manufacturer is focusing a lot on battery tech. And I am here at the Mahindra Research Valley, or MRV, where Mahindra has set up an all new battery development lab. And talking to me about this and more, I have Mr. Velusamy, who's the president of Automotive Technology and the deputy managing director of Mahindra Electric Automobile Limited, to tell me what they are planning for their future EVs in terms of battery development and testing. Velusan, thanks very much. So clearly this is a new setup. So can you explain, batteries, obviously the most critical component, but it's not so much of just getting a battery and plugging it into the vehicle and off we go. I mean, there's a lot that goes behind it.
Absolutely. Thank you so much for Hormazd coming over here and then trying to understand what we do. So here we build the prototype batteries, and these batteries are built according to specifications, but we don't know whether they deliver the performance specifications that we have laid out. So we have series of tests of the battery packs here. So at module level, at pack level, and its performance over voltages, its safety performance, its vibration performance, its thermal resistance, and water resistance, so much so forth that we need to do to qualify this heart of the vehicle systems. And it's difficult to explain, but easy to show you inside the laboratory.
Right. Before we go in, I just want to talk one thing on safety. Now, there's this perception batteries and fires, and we see it on the news. We see it all over the place, and it becomes big news, of course, every time an EV catches fire. Luckily, they're not having so much, not happening that often. But is thermal issues or fire one of the big things you need to guard against?
Yes, so the design has to be made very, very robust. There are high performance batteries like NMC, there are standard performance batteries like LFB. Both need a different sauce to maintain the safety. Both have safety topics, and we need to design it right from the beginning, and we need to know the chemistry very well.
Before we go in, NMC versus LFP, there's always been a debate on that. Obviously, everyone's become an expert in that. Is it fair to say that both are safe? It's just that NMC sometimes requires more precaution than LFP, or is it fair to even use an analogy like NMC is like a petrol engine, has more punch but needs a lot more, let's say, thermal management, and LFP is like a diesel where it's not as flammable and needs less management. I mean, do you think that's a right analogy?
You said it. You
Right.
said it. It is originating from the structure of the crystal layers.
Right.
NMC is layered structure, and LFB is an olivine structure. So the ability to release the oxygen in the layered structure is very easy, and therefore NMC is little bit more prone than an LFB. But you have other measures to control it, and therefore you can make a
Just like a petrol engine.
just like a petrol engine. You can make a nice structure. You
Right.
can make a nice safety battery packs.
Great. So we're just going to head inside and let's talk about more on how some of the testing is being done.
Super. Come
Thank you.
inside. So this is the newly constructed battery and motor development centers.
Right.
So that's the the battery, what we call it as 79 kilowatt hour battery
So
pack.
this is your 79 kilowatt hour battery pack. This
battery
is what's
pack.
going to go in your.
The
This is part of
BEVs.
your INGLO platform.
INGLO
This is really
platform.
the heart of your
Part
INGLO.
of this system.
Right. Looking at it, it's obviously these are I think blade cells, very compactly done, not
Yes.
not too much wastage of space, very space efficient.
Yes.
Velusan, can you just tell us? It looks like a nice flat, very neat square, but obviously a lot under this.
Yes. So first and foremost is for a battery designer to pack as much cells as possible.
Right.
That's what we have done it. We have explained in 15th August 2022. This is a cell to pack technology. So what you see here is all the cells are very nicely packed directly into the battery pack. So we have 128 cells that we explained. that gives us 79 kilowatt hour energy. We have a cooling plate that runs underneath the battery pack that gives an incredibly best cooling performance. The secret of which we will tell you
Right.
during the
So cooling and keeping a battery cool, a bit like a baby, it has to be in a operating window of a certain temperature.
certain
So could
temperatures.
you explain on the cooling part of it, especially given our conditions where we are in very high ambient, you know, Rajasthan 50 degrees Celsius, that sort of thing. How do you kind of address the cooling issues for batteries in such high ambient
So there
conditions?
are one is how much cooling that you give. One can say, okay, you give so much cooling so that you are able to give. That's not the real answer. The real answer is, suppose you have 128 cells. What is the cell-to-cell variation in cooling performance in your cooling system? The highest uncooled cell or the cell that has the highest temperature will determine what is your allowable energy output
Because
from
at
the cell.
one cell, if the
That one
temperature
cell,
spikes, the whole
yes,
system will shut down in
it
a way.
shut down. So cell to cell difference, people accept up to 5 degrees centigrade. In our case, we targeted about 2.5 degrees, and in development results, we have achieved 2.5 degrees.
Right.
So, for example, if I say the cell, the battery has reached 31 degrees, the one cell that had the 2.5 degree compared to the other cell will reach 31.5. The remaining is 29.
Got it. Got it.
28.
But Velusamy,
So,
how do you have such a consistency across such a vast area? Is that really the
so
way to do it? Because cooling, I mean, you know, to keep it consistent and have it similar temperature.
So this is where the cooling channel design and
Right.
the analogy comes. So in your human, we took the analogy of human nerve centers. So everywhere, wherever you touch it, immediately it will reach to the brain.
Right.
There is no
Lag.
lag in the system. So that is what we wanted to try to achieve. And then we took something inspiration out of that. And there is an innovation in that and patent out of that.
Right.
And we have applied for it.
When can we see that?
And when we reveal it in next year, we will give you more details of that, how the cooling system works. Before we go to the testing lab,
Yeah.
as you see, the wiring harness runs in the middle and you have 128 cells and you have all the tappings, positive and negatives. There are so many contact points, they are welded, laser welded. Now,
Laser welded.
laser welded. If they, one of them give away, then you have to down the whole battery pack. That's the
Right.
danger. And the removing the battery pack out of the vehicle and putting it back is not an easy job. So by design, we have to ensure that all the electrical connections that are done for the 128 cells are absolutely foolproof from anywhere water leakages, vibrations, and when the crash takes place or accident takes place. A side crash or the frontal accident takes place, this should be absolutely foolproof. So the system should be able to isolate this battery, disconnect this battery, high voltage battery immediately from the vehicle. And these are the systems that we tested here inside before we qualify the battery to be fitted in the vehicle.
Right.
So let's go and
Let's
see
do it, sir.
inside. Of course, these batteries, each module have to be tested for its performance.
Right.
So if you have 8 modules and these 8 modules integrate their performance to give 79 kilowatt hour.
Right.
So each module, which is in the front or in the rear or in the middle, they all have to deliver exactly the same performance.
Right.
So our endeavor is to make sure that all the modules are delivering exactly the same performance levels. So we built it this
Wow.
uh, this facility. It's a very solid, thick 2 feet wall. If any fire takes place inside, it doesn't go out. It's
Okay, so this
completely
is
isolated.
thermal proof.
Thermal proof. It's completely isolated with a complete fire hydrant system. So here is the pit that you see where we can drop the complete battery for
Down in
30
here.
minutes into the water, which in the South Africa you might have seen the videos.
Yeah.
And then we take it out, and then in the battery build area, we open it and see whether water has gone inside or not.
So tell me, this is where you do the leakage test.
Yes,
Right.
what leakage is.
So how is a typical leakage test done? Is there a certain
So
amount of pressure or what?
So if the water has gone inside in a charged battery pack, you will have short circuit and then you will have
Fire.
fire. So you cannot test it outside anywhere. You have to test it in a place where you can test it. So that is this place. What you are seeing is
What is this rig over here?
this is the battery pack in the z-axis
For
running
vibration?
vibration.
Ah,
So as you can see, this is a very high frequency, low amplitude. Very high. Can you see it?
right, yeah.
This is so you have an random vibration signal where across in the road you have a road inputs coming from the tire to shock absorber to the chassis. Uh, in the chassis you have a lot of vibrations, and all the connections, the laser welding connections and the
Have
128
to
cells
withstand those vibes.
have to withstand those vibrations, and we apply and run the complete cycle. What we have seen in accidents, even in the safety GN cap and Euro NCAP, the cars reach until 30G. When the point of accident, where you are driving maybe from 120 km per hour to 0 km per hour in milliseconds, in 12, 13 milliseconds, you reach to the value of 30G. So when you apply 30G, the modules and the cells that are sitting inside, they should not displace and then create a short circuit. If
Right,
it creates short circuit, then immediately safety issues
yeah.
will happen.
So I think Velu, the main thing, I think the key thing is preventing the fires. A lot of things that create fires.
Yes.
One is water can create a fire,
Yes.
vibration can create a
Vibration can
fire,
create a
the
fire.
punctures can create a fire.
Punctures can create a
So
fire.
basically, it's the fire which is the biggest worry,
Uh,
and to manage that.
Manage that. And second, you don't want to have any reliability problem.
Right,
Even in the case of accident, you should be able to use the battery.
right.
In the front end got damaged, okay, you can repair it, but the battery you don't want to repair it.
How is it compared to an ICE vehicle? I mean, is it more difficult? Are there more learnings? I mean, what is your sense, or
So
is it
a lot of people told me there are very less moving parts in
EVs?
EVs. But as we design and develop the battery pack and motor and this, yes, lot of rotating parts inside the ICE engine were there, and it is not here. But lot of high voltage connections are there.
Different challenges.
Different challenges. I mean, it has to be absolutely waterproof. It has to be absolutely vibration proof, and it has to operate at a multitude of temperature levels from minus 30 degrees to plus 80 degrees. So this chamber, for example, that you see it here,
This chamber.
this chamber is the battery pack is inside, and then you cool down to minus 40 degrees.
So this
And
can go down to minus 40.
minus 40 degree, and then you rise it up to plus 80 degrees. That's a graph that you see. Plus 80 degrees. Right now this cycle is running for plus 50 degrees, 50 degree temperatures, and then this can come to minus 40 degrees. So it gives a thermal shock to the whole battery pack. So the different materials are there inside. You have a cell, then you have all laser welding connectors, wiring harnesses. At different temperatures, they expand differently.
Right.
Then they can disconnect on their own.
Right.
So, for example, you go to Ladakh, Leh, and then you have minus 20 degree, 25 degrees, and then you drive down to Rajasthan, you have plus 50 degrees, you experience a different temperature profiles.
Right.
And the battery pack should not have any disconnections inside.
Right.
So that is a reliability topic.
Right.
And in these temperatures, you also do 0.5 C charging, discharging, 1 C charging, discharging, 1.85 C charging, discharging. That's what we do. Charging, during charging, we allow up to 1.85. That allows us 30 minutes, 80 kilowatt hour to be charged. All that we have to, for example, in Leh, at minus 30 degree, I have to ensure to the customer that in 30 minutes he is able to charge the fast charging with 160 kilowatt charger.
Right.
In 30 minutes he should be able to charge 80 kilowatt hour. That's
Right.
exactly we do it here.
Right. This is the temperature variation.
Yes.
Velu, I want to just talk a little bit more on battery safety.
Yes.
You've got NMCs which are there in your XUV 400, pouch cell, that too. Obviously, that's different challenges. Your next gen of EVs are all LFP. How do you manage the kind of testing for all this? Is it some require different protocols and different approaches?
So the LFP is
Safer.
safer.
Right.
But you have to manage the cells to get more energy out of it, because
Right,
in a given space, it is very difficult if you don't design it properly.
right,
But then you can, the more number of cells, the cell volume we call it as,
right,
more number of cell volume in a pack volume
right, right,
is
right,
the
right,
key there.
right.
So that's the key in case of LFB. In case of NMC, you get it that in any case,
Yeah.
but then how do you put the anti-fire
Measures.
foams,
Yeah.
silicon or silicon mica or mica plus some steel, whatever you can put in between. So if there is, if you have 200 cells or 190 cells, how do you arrest the fire within that particular cell where the problem occurs
And
and not
contain it
allow,
there.
yeah, because 80 kilowatt hour is combination of all the 128 cell performance.
Right,
Now, if I am able to, if the 80 kilowatt hour burns, then the whole battery burns.
correct.
But if the fire starts with one cell,
Right,
as long as I am able to isolate only one cell, then I am not allowing the fire to propagate. So
right,
that's called thermal propagation test.
right,
So a lot of measures that we do is from that point of view, that
right,
if you are not able to avoid the fire, but avoid the fire propagation,
right,
that's the measure that typically people do it in NMC.
right, right. So
Uh,
that's the way
that
it is.
that's how then you do the complete testing there.
One more thing I want to talk about is the battery regulations. Clearly, you know, do you think it's a bit over-regulated? We've got so many regulations right now. We suddenly have this whole set of regulations which has come in. Obviously, a lot for safety, but are they practical? I mean, each cell has to be tested. It seems, I think obviously after the certain fires of two-wheelers, which kind of give everyone a scare, there's been a real clampdown or really tightening of battery safety regulations.
I
Just wanted your thoughts
am
on that.
I am not sure because if you look at the battery regulations in China and in Europe, they are, all of them are there in a way
They're similar.
similar. So and the EV industry can get killed if the battery is not developed very well.
Right.
So I would rather do a very perfect job on battery and get it right, because it is at the end of the day customers.
Right. So clearly, I think, but does that pose a lot of challenges in the terms of does it slow down development, or once you know what the procedures are, you can
No,
it's pretty
the
straightforward.
technologies what we are developing is for the global standards, for the
Right.
European market, and of course for the Chinese market automatically gets into it. Um, we don't see a very difference between European market and the Chinese market and US market. As long as you are developing it for the overseas market, you will over fulfill for the Indian market right now, but that's what we want to do.
Right. So over fulfill for the Indian market in terms of regulation. I
Yes.
think that's how it is. So
Yes.
so but
For example, nail penetration test.
right.
Our battery, when you do the nail penetration test, I have shown the videos in South Africa, it doesn't catch fire.
Right. So, Velusan, in your, what do you think is the biggest safety risk for a battery right now? Which you have to is it accident? Is it penetration? Is it ambient temperature? All of the above, or what is the areas which really give you, I wouldn't say sleepless nights, but where you really think is the most critical areas you need to focus on in terms
Um,
of the reliability and safety of the battery?
I think it is the consistency of production is the key, because what you have is the laser welding of 128
So
cells,
basically, quality control.
quality control. Once you assure that, and then is the cell production, the cathode, the
Separator.
electrolyte, and the anode, its thickness and its quality.
Right.
So as long as they are, the quality is controlled, rest everything is
Right.
rest everything is controllable, because then you have a BMS to control.
Right.
The quality of BMS software plus the software calibration is so important that you go to really every place. We are currently running BEVs in Leh, and we are learning lot. Every day we are learning lot. So that learning has to go into the BMS.
Right, right. And last question, Velusan. I mean, clearly it's been a phenomenal transformation going from ICE to BEVs. You, as a person who kind of literally fathered what I would say is one of the finest IC engines, now moving to BEV, how's the transition been? And especially where do you feel the maximum learning has come? Is it obviously from the battery and understanding it as the secret sauce of EVs?
Yes, three areas the learning has come from. One is obviously the battery, the cell chemistry, um, absolutely different. It's beyond mathematics. It's very intuitive, um, and the systems needs lot of care in designing. So you have to really understand it, and before you step in, we really didn't think in the beginning that we can get 80 kilowatt hour with an LFP cell. But it took us about 6 months, but we were waiting. At the end of 6 months, we cracked this, how to do that one. Because the LFP is very stable chemistry. It is not dependent on nickel, lithium, and cobalt.
Manganese and cobalt.
The manganese and cobalt. And then it is 15% cheaper than NMC. You can see Elon Musk, what he is doing is buying LFP cells and fitting it all over his cars and selling it instead of NMC
And life
cells.
cycle point of view also is
Life
better.
cycle point of view is better. So it's the biggest learning is in terms of the battery cells.
Right.
Battery cells is the biggest.
And you know, honestly, XUV 400, a big learning for you all. You know, you've had challenges in the market, gone with an NMC 532. I mean, any learnings from that? Clearly, it was kind of designed and conceived about 5 years ago. So you went down a certain path on that. But I'm sure there must have been some learnings from that.
So in XUV 400 there are multiple things. It was sourced and designed in 2017 or so, and then the program. So the commercials are different, and,
Right.
and you know this. There is a point up to which you can operate, you can do the business. And second is, as I explained, one is the battery, the electric part of it, motor and battery. Whatever technology you do, whether it excites the customer or not, maybe the portion of the customer who are green world, it will excite. But the other thing is, how about autopilot, autonomous driving, drive assist, and then the multiple technologies of the ambient lighting,
Correct.
you know, ADAS multiple levels, 5 or
Right.
1V, heads-up display, uh, audio system. We introduced Dolby audio system. Dolby audio system is one of the best. Dolby Atmos is one of the best audio systems. I think it is the overall experience that is going to matter to the customer rather than one or the other.
Right.
And then XUV 400, maybe we have introduced the electric in the current vehicle,
Right.
which is due for a mid-cycle
Refresh.
refresh. So when the mid-cycle refresh comes in all across the volumes, all across the products, then we think it will.
Right. But clearly, it's a stepping stone to your next generation of Born Electric's INGLO platform. I'm
Yes,
sure that's what
every learning is great for us.
Right. Velusamy, thanks very
Thank you
much.
so much.
Thanks so much for showing us around, and wish
Thank
you all
you.
the best. Thank
Thank
you.
you so much.
Thank you.
Thank you.